Alright, in this video I'm going to pick up with inverses from equations, and before I do I want to kind of give you another example of inverse just so you get the idea of it. So let's just say you go to the vending machine and you put your money in for a, let's just say that you want to get a Powerade and you want cherry. And you put your money in and you accidentally hit the wrong button and you get lemon lime and you hate lemon lime. Alright, so let's just, at this point we know in reality you're kind of stuck with the lemon lime. But let's just say that there was this machine that you could put the lemon lime back into the machine and it would give you your money back. Okay, that's an inverse. So the first machine you put your money in and you got your product out. The second machine is you put your product in and got your money back. So that's kind of like what an inverse is. Again, another example. Inverses from equations are a little tricky sometimes because depending on the complexity of the equation will depend on the complexity of finding its inverse. So first of all, let's start out with the fact that there is some notation for inverse functions, and that is this little excuse me, this little negative sign right here. And that doesn't mean invert or reciprocal, okay? It's not a power. It's just simply a label, okay? And so we'll take a look at that here in a second. So if I had a set of ordered pairs, we put the 2 into the function and got out a 7. The inverse would be I'd put in the 7 and get out the 2, kind of like the vending machine example. Just a little bit more boring than the vending machine, I'm sure you agree. In like manner, without notation, if we just looked at 2 functions, okay, they look like normal functions, and actually we don't even know if they're functions for sure because we don't have the label. But these are inverses of each other, but you would never know it. So the purpose of using this notation is for you to see which one is the inverse of the other. So I'm going to let this one be f of x, and I've already figured out its inverse, and it's the second one, but you would never know it unless you used the notation. So now by looking at it, I can tell that these 2 equations are inverses of each other. See, with ordered pairs, you can easily see that they're inverses because you just switch the x with the y. But with equations, it's not so easy. So let's just take a look at these examples you have in your notes. And we're going to start with this basic function of a line. We know it's a line because it's y equals mx plus b, and we should all know that, right? Well, anyway, so to find the inverse of an equation, you just simply, let's just replace the f of x with a y for right now, because that f of x gets a little clumsy. Y is just easier to manage because we're going to switch the x with the y. Okay, so in our second line, we're simply going to trade the x out with the y, kind of like what we did with the ordered pairs, but this time we don't have numbers, we're just going to have the variables. So again, you just switch it out. And now what you're going to do is you're going to solve for this brand new y. So you're going to use some inverse operations to do that. Okay, first thing you're going to do is you're going to add 2 to both sides. And you get x plus 2 equals 7y. And then you're going to divide both sides by 7. And you will have isolated the y. You know me, I like the y to be on the left-hand side, so I'm going to switch this over. But again, now I can't tell if this is the inverse, so I am going to use my notation. And so here was the original function, and here is its inverse. Now I'm just going to show you a way you can check your answer. You don't have to do this every single time, but it is interesting to see. So I'm going to start with the original function, and I'm going to pick a random value. Some of you are going to freak out because you're going to say, where'd you get the 1? But I'm just going to pick any x value. And I like to use the number 1 because it's easy to use. And I'm going to evaluate this function when x is equal to 1. So 7 times 1 minus 2 is 7 minus 2 and 5. So the ordered pair is 1, 5. Next, I'm going to take my inverse function and I am going to plug in the 5. And what I should get out is the 1 if they're truly inverses. So this time I'm going to plug the 5 in for x. 5 plus 2 is 7, and 7 divided by 7 is 1. And so the ordered pair is 5, 1. So from the last video, remember, to find the inverse of a set of ordered pairs, you just switch them out. So this is proof that this equation right here undoes this equation here. It gets the numbers back to the other island, so to speak. All right, so let's take a look at a little bit more complex equation. This one is still a line, but we got some fractions in there, and we know how we feel about fractions. We hate their guts, but anyway, let's just proceed. And the first thing I'm going to do is change out this for y. Next, I'm going to switch. We're going to switch sides. X is going to switch with y. You just replace. And now I have to isolate this y. And I have some options. I could distribute the 1/3 and get some messy fractions. Or I can remove this first. And I can take its reciprocal. The reciprocal of 1/3 is 3/1. So when I multiply this side by 3/1 and this side by 3/1, the fractions disappear. Ta-da! There I go. 3x is equal to 2 minus 2y. You got to know these little tricks. You'll learn them as you go. Next, I am again in the process of solving for this y, so I'm going to remove this 2, and I'm going to do so by subtracting it. There it is. Don't drop off that negative. Next, I'm going to divide everything by -2, and that does some really funny things to this left-hand side. This negative is a floater. It can go to the upstairs. So that's exactly what I'm going to do with it, is I'm going to pull it to the upstairs, and it's going to switch the signs of the upstairs. So again, how do I know that this is the inverse equation unless I use the notation? So again, don't get confused by this really complex looking figure right here. It's just a label for function, the inverse of a function. All right. The last way is fairly easy. It'll be a really short video, and I will pick you up where I left off.